Hi, I'm Schlaephfer. Let's talk about the ADK 2012. With me. So just to finish the introductions, over here is Dmitry Grinberg, who worked on the software. Also over here is Travis Geiselbrecht, who worked on the software as well. And since I didn't mention it before, I worked on the hardware for the ADK 2012. So first, let's talk about accessories for Android. There's a couple of ways to connect accessories to Android devices. That includes USB and Bluetooth. So through USB, we can use last year's Android Open Accessory API. And through Bluetooth, there's a variety of protocols for a variety of purposes that we can use. And so a lot of the accessories you can build here, commercial purposes include audio dock, exercise equipment, medical devices, that kind of thing. But there's also a lot of capability for hobby projects as well, such as a robot controller and all kinds of wonderful things that people can do with this. So I'm sure you're dying to see what the ADK 2012 looks like. So let's just go ahead and take a look. And here we have it. We've attempted a little bit more than we did last year. All right, so what is this thing? This is an alarm clock. You can take it out of the box and plug it in and begin using it as an Android-connected alarm clock right away. It's also an audio dock. If you plug it into the USB connection, you can transfer audio from your phone to the device and play it back in real time. You can do exactly the same thing over Bluetooth as well. And it also acts as an Android accessory hacker platform. It's totally extensible. You can go in and edit all the code. You could even go in there with a soldering iron and make all kinds of changes to it. So let's talk about some of the features here. We've loaded it down with a lot of good stuff this year. So we've got a light sensor in the corner that can sense ambient light levels, proximity, and it has a built-in colorimeter, which we'll talk about a little bit later. There is a capacitive slider control on the top for adjusting the volume, adjusting brightness, color, all kinds of other functions. And we've put in a bunch of capacitive buttons as well. In fact, almost the whole front panel is capacitive. There are also 64 RGB LEDs. So all those 7-segment display segments here, you can control the color, set them to whatever you want, display patterns, all kinds of cool things. Okay, now I'm sure you're wondering what's inside. So let's go ahead and take it apart. It's very easy. You just squeeze the case. There's not a single screw in this entire design. It's held together by magnets. And here it is, unfolded. This is one of the first devices that's actually designed to be taken apart, because we want you to take it apart and hack on it. So on the inside, let's look at some of the component pieces. On the upper part, there's a speaker, and we use that to play back alarm sounds, audio from Bluetooth or USB. And if it looks a little odd to you, that's because it's a transducer. It connects to the back panel of the device, and it uses the entire back surface as a speaker. So you get big sound out of a small device. There's also a whole bunch of sensors in there as well. The ADK is aware of the temperature, the humidity, the barometric pressure, the acceleration, and even the local magnetic field. Just imagine the potential for that. Also, on the side of the device is an NFC tag. So when you first get your device, you can take your Nexus device and hover it over the tag, and it will send you to the App Store to download the app. Let's talk about the microcontroller. I remember last year we had a little AVR processor, a little 8-bit processor, and it's a great little processor, but we decided to do better a little bit this year. So this device has a 32-bit ARM Cortex M3 processor. We've connected a Bluetooth device to it and an SD card, and if some of the stuff looks a little bit familiar, that's because it's completely programmable through the Arduino IDE. So if you don't want to use it as an alarm clock, you can actually take it apart and pull the entire board off of it, and it's an Arduino, except it's 32-bit. So instead of writing code for a processor running at 16 megahertz, you can take that same code and run it at 84 megahertz. Okay, let's talk about the phone application. So again, if you take your Nexus device and you hover it over the NFC tag, you can pick up the application. You can plug in through USB, and that will automatically load the application for you. Once you've launched it, it'll give you a little connect menu, and so you can use this to connect through Bluetooth, which is pretty straightforward. So just search for devices on Bluetooth, and it'll show up as the ADK 2012. Click the connect button, and it will show a little code on the front of the device. You can just click OK here and pair up. And once you're done, launch the ADK application, and click Use Bluetooth, and then pick it off the menu, and you're done. That's it. So one more step than you would have to use for a Bluetooth headset. If you want to connect it through USB, you do what you would do last year. Just plug it in, and it works. Magically launches the application. And once you've done that, you'll get the main screen here, which has a number of different functions here. You can set the time. You can set the alarm, set the color. You can choose some display settings. And you can lock the device as well, so you won't actually accidentally brush up against the cap sense and change your alarm. Setting the time is very simple. You get a little time picker like this. And if you just click through that, it sets it to your cell phone network time. So it's a very quick way to update the time on your alarm clock. Alarms are similarly easy. You can just come in, click on the menu, set the alarm time, and you get to choose the alarm sound. There are a number of sounds that we preload onto the SD card, and they're all in the open source OGG format. You can put all your own sounds on there as well, and we've got a built-in OGG Vorbis decoder. All the source code is right there for you to look at. Okay, now let's talk about setting the LED color. And there's a couple of ways to do it, but my favorite way is something that Dmitry here will demonstrate for us. So let me go ahead and switch over to his screen, and so we can see the clock that he's been operating here. Okay, so Dmitry, go ahead and show us the color picker mode. I did tell you about a colorimeter. Okay, so he's got
for example, we can grab different colored swatches and have the device pick up their color.
And so, of course, you can do this from the application as well. But just imagine the possibilities. You could take, for example, little colored jelly beans and make a robot that can recognize the color and sort them. I mean, the possibilities are endless with this type of sensor. You guys will love it. OK, I'd like to pass things off to Dmitry now to talk about Bluetooth sound and storage.
Thank you, Eric. So as Eric mentioned, we added Bluetooth to this device, by which we mean we added real Bluetooth. A lot of Arduino projects and similar small embedded devices use Bluetooth to serial converter chips, which just give you a virtual serial port. That's all nice and great, but it doesn't give you too much flexibility. So here in the ADK 2012, we have a real Bluetooth chip. It's a TI CC2564, and it's connected over UART to the main processor. We have the onboard antenna, so everything you need to do to play with Bluetooth is right in the ADK. We wrote our own little Bluetooth stack for the ADK, mostly because it's a very simple one. It runs on bare metal, and it's BSD licensed. So you can just grab it and use it. You don't have to pay anyone any royalties. You don't have to disclose your code, nothing. It is very simple. It supports multiple concurrent connections. We implemented a Service Discovery Protocol server, so you can advertise your services so devices can discover it. And if you do want RFCOM, which is a Bluetooth serial, we have that as well. Here we have a few lines of code just to show the functionality we have available. You can set your device name, get remote device names. You can do device discovery. You can make your device connectable, discoverable, everything else you'd expect out of a Bluetooth stack. If you want to play with low levels of Bluetooth, you can use L2CAP protocol, which we give you access to. You can create L2CAP sockets. You can receive connections on them. It's all extremely simple to do. Whenever data arrives, a callback gets called, and you can process it, and you can send data back with a simple function call. The data is sent asynchronously, so in fact, you don't have to keep it around. You don't have to worry. It'll get sent whenever it's needed to. You just call one function. And this is something you would use, for example, to implement Bluetooth HID if you want to have the ADK pretend to be a keyboard. But of course, the way Bluetooth discovers what services your device has is SDP. It allows devices to query and receive responses about what services your device supports. We have a fully working SDP server in our device that supports the entire SDP spec, so you can discover services on here. The API is, once again, extremely simple. You can just add and remove descriptors using two functions, And as soon as you add a descriptor, it begins being advertised. And of course, the ADK source code includes examples of this, because that is how the phone application communicates with the ADK. For virtual serial ports, of course, we have RFCOM, which acts to you just like a serial port. You'll get a callback when data arrives. You can call a function to send data. And once again, the example is in the ADK. We support multiple connections, and it's actually quite fast. So I've tried making a small ADK application that just pipes data back to you, and we got 1 megabit full duplex throughput through this chip and through the entire ADK code stack.
So kind of what this means for you guys is that not only is this protocol stack completely exposed to all of you, you guys can look through all the lower layers, all the upper layers, but RFCOM is a great way to get started with it. So if all of these acronyms don't really make a whole lot of sense to you, if that's something you don't want to dig into, then you can just look at this example we have on this slide right here, and using RFCOM, which is the simplest serial protocol, is literally that simple. So it's very scalable.
And we've tried this with multiple OSs, not just Android. It works with Linux and a few other OSs we've tried as well. And the other thing we added to the ADK this year is A2DP support. So the ADK is actually a fully working Bluetooth speaker. We have an SBC decoder in here. It supports mono, all 3 stereo versions, everything you'd need out of a Bluetooth device. And we've also tested it with multiple OSs, including Android and Linux, and it does work.
Would you like to demonstrate that now?
I don't know if I have any. I guess I can play some alarms. Sure.
Let's give it a shot. I'm not sure what the 2.4 gigahertz spectrum looks like in here, but we'll see
We'll
what
find
happens.
out soon enough. So
Let's consider this a stress test of the Bluetooth stack. So if all these people with Bluetooth connected phones out here, and I can imagine 2.4 gigahertz right now, let's take a look and see if this will, well.
I want to see what ringtone I can grab.
I hope you've already paired with it, because you're going to get a very long list of devices.
I imagine so, yes. There, well, I guess it's not very loud, but you can hear it.
And it's ringing. Your alarm clock is ringing.
It's not playing out of my phone. You heard it out of the ADK. And on the phone side, the Bluetooth is very, very simple. So for example, here is an RFCOM sample for you. And it's very easy to make this work. This is literally the code you need to communicate with the ADK in the simplest form. You create a connection, and as you see, we do a discovery using this UUID. This is just a UUID you create yourself, and as long as it matches on the ADK side and your Android side, the connection will be made. And then you get an input stream and an output stream. So in Java, you just send bytes and receive bytes. There's no further complications for you to deal with. One of the other additions this year to the ADK, as you've just seen, is sound. And we've made it really, really easy for everyone to use this. So the audio data is piped to the audio digital analog converter using DMA. So your code doesn't have to conform to any timing requirements or really do anything complicated. It just works. The API is very simple, as you can see. You can just enqueue an audio buffer, and that buffer gets played whenever the audio hardware gets to it. And the code will block until it's time to do that. Or you can use instead a try audio buffer, and that way you can know if the current audio buffer is already full. The thing you see there with the source is one of the interesting things about the ADK. We didn't want to put a full audio mixer in it, not because we couldn't, but we just didn't think it was appropriate. So instead, there is some code in here to do audio lockout. So there's a fixed priority of services. For example, alarm overrides anything else. So if you try to play a file while the alarm is going on, alarm wins and your data gets dropped. And of course, this is all code you can modify. So if you want to add your own audio mixer, you're free to do so.
What this means for the people that are going to use it as an alarm clock before starting to hack on it is that if you set up and you've got music playing on it, and then the alarm goes off, the alarm will interrupt the music, just like you would expect it to.
And we went a little further than that, because no one likes uncompressed audio. So as Eric previously mentioned, we did have an OGG decoder in here now. So the alarms that are in the device are OGG format. And the API for that is extremely simple. The simplest way is just to call play OGG and give it a path. That's all you have to do. The audio will just start playing. Also, you can do it in the background if you wanted to. And we also have a global volume control. For storage, we have a micro SD slot on the device, and all the devices have a micro SD in them already. And the API is very simple, as you would expect. There's an SD driver in place and a FAT16, 32, and 12 driver built in. It's got all the functions you'd expect. You can open files, close files, read them, write them. You can create directories. A few things that most embedded file system drivers don't have. You can also format a card or move files. And this is all, once again, code you get, code you can modify, reuse, whatever you want. Now I want to hand it over to Travis to talk about some of the USB things.
Thank you, Dmitry. So the ADK also has USB, as it did last year, and it's similar today. Dmitry's going to show us the 2 ports on the back. In fact, that's the inside of it. There are 2 USB ports on this device. The first one is used for programming. It looks like a standard FTDI-based serial port. That's the one you use for debugging and
I think you're on the wrong side.
Yeah,
there you go.
This thing's upside down. It's really hard.
Yeah, see, so there's
Oh,
2 ports here. They're both micro USB. The other one was one that's really interesting. That's a USB host port. So on ADK1, there was same thing, USB host, but it was implemented as an external chip that actually handled most of it. For this time around, we actually pulled the host stack into the ARM processor. In the case of this particular ARM, it had an on-the-go USB controller. So we put it in host mode and implemented the stack. So the full source is available. It's running on the ARM. It does everything that we'll talk about here in a minute. If you've never used Android Accessory Protocol, it actually shows up in an inverted way that you normally expect. The device implements host, the accessory device, and the phone or tablet or round sphere of something shows up as a actual device to the ADK. And really, the nitty-gritty details is there's a little handshake at the beginning, and then it ends up exporting 2 bulk endpoints, and it's just data in and out. Very similar to what we did last year. And then it's up to you to format whatever protocol you want.
So Travis, you did mention a sphere, and what you're referring to is the Nexus Q demo that's happening right now on the 3rd floor with that giant ball and the robot arm and all of that. That's all being done through an ADK2 from a Nexus Q using the Android Open Accessory Protocol.
Yeah, so actually, if you look there, there's a ball. And that's running an Arduino sketch that was written a couple weeks ago. You've actually already seen one, and most people hadn't recognized that it was actually an ADK.
It was at that point I really appreciated the power and simplicity of Arduino because we were down to the wire and I had to get this thing done, and so I just whipped up a quick sketch and it worked great. As you can see if you go up to the 3rd floor. Go ahead.
Oh, and so also here's the list of the API. It's a very simple API on the device side. For the accessory protocol, most of the actual API is setting the different strings which is what your device will show up to. There's a list of strings that you can match against where you can name yourself, in this case ADK 2012 or my cool widget, and that's exactly how the app on the Android side will know which app to connect to or what the protocol version is. So most of the API is just for setting those strings. And at the very bottom, you basically have 3 calls. Are you connected? Send data, receive data. There's not much to it. It doesn't format it. It's just a string of bytes. It's up to you to define whatever protocol you want. In our case, we actually developed about a 10 or 15 opcode send and receive protocol to support all the sensors and whatnot on that. And we used the same protocol to punch over Bluetooth as well, so it's quite straightforward.
So you can look at the sketch that we'll provide with the full source code and see that as an example of sort of a medium complexity example of transferring data back and forth over USB.
Right, and this is actually essentially the minimum setup. You'll see at the top we initialize the ADK and set the accessory strings for whatever your device will show up as. And then in the main loop, you basically are just testing, are you connected, are you not? Send data, process it, send it back. It's not much to it. It's a little bit more complexity on the Android side, but this course is not any different from last year. The accessory protocol's been in Android since Gingerbread. But for the most part, you set up the connection, and you do a little bit more error checking than on this slide, but probably about twice as much code in the final solution. But then at the bottom, you end up with 2 input streams, input-output stream. You punch your protocol over that, and that's pretty much it. Not a lot to it. There is a little bit of string matching that you do inside the app to decide which device to connect to, and of course Android lets you register a particular app to start automatically when it sees this particular accessory, and that's all handled inside the manifest of the app.
So if you notice that the last two lines look familiar, you're right, because we use the very same stream mechanism for Bluetooth. In fact, in our application, what we've done is we've abstracted it and wrapped them in two different classes that both inherit from a master class that has two stream objects. And that allows our ADK application to use either USB or Bluetooth with exactly the same code. And you, of course, can use that code in your own projects as well.
And there's one more feature that we added for this one, and this is new since last year. Part of a feature that was added in Jelly Bean is there is a generic USB audio mechanism. And it's an extension of the Accessory Protocol. And basically, this is, well, of course, documented on the Android side. There's actually no API involved, which is why there's no code to actually show you. But basically, it's a little handshake that happens when the device goes into accessory mode, and then the phone, or tablet, or round spherical thing, turns into a USB audio device. Basically looks like a microphone, more or less, to this. It's full 16-bit, 44.1 PCM data, no compression or anything on that, like that. And what we're using this device for is essentially an example code. Right? Here is an example of how you would go implement it. You might not even use this exact code, but if you're designing something based on a PIC or an AVR or something more exotic, you could also use the same thing. This is, of course, well documented, so this acts like a example to it. Same thing with, and like I said, this is in Jelly Bean and above. All devices have it. If it's got Jelly Bean, it supports this protocol.
So what this means for all of you is that you can take your Jelly Bean Nexus that you got here, plug it into your ADK, and without any menus or configuration or anything, you can immediately begin playing audio through it.
Yeah, you'll see a little pop-up that says connected as an audio device, and then that's it.
And then it just works.
Yep. All right, so I'm going to hand it back over to Eric, who's going to go through the rest of the fun gadgets you can do with it.
The pretty lights. Let's talk about blinking lights. There are 64 RGB LEDs on this guy, 6 7-segment digits, 2 colons that you can control separately, 8 icon indicators, and 12 party mode lights. I can't wait to see what you guys do with those. That'll be fun.
Camera 3.
Actually, I think Dmitry might have done a little bit of a demo here, so let's go and switch over to that camera and take a look. So he's actually been busy coding up a bunch of different demos. Dmitry, that looks really good. He's been going through so many different visualization algorithms over the last couple of days. I just look over at his desk and, oh, look at that. There's another neat pattern. Very cool. So I'd love to see what you guys come up with as well. Please go and record videos, put them up on YouTube. I look forward to seeing all of that. So the API to control those LEDs is very straightforward. Since we handle all the LED muxing and the LED controller in the background through an interrupt-based system, there's really not a whole lot you have to do. Just LED write, put in the index of the LED, and the red, green, and blue values, and then it just sort of magically happens, and you don't have to worry about anything. If you want to get more complicated, you could use the LED draw letter function and put in essentially an ASCII value, and that will show up on the digit that you've selected. Now, granted, it's a 7-segment display, so certain letters like M and N and some of those other tricky ones we can't display, but we do our best. So play with it and see what you think, and those are the LEDs. Let's talk about the capacitive touch sensors. There are actually 12 buttons, one each for the up and down on each segment. And what that allows you to do is if you're in clock mode, you can set the clock just by touching the top or the bottom of each digit. Dmitry, did you want to demonstrate that?
Why not?
OK, let's switch to the camera and take a look here.
So
it's a little hard to talk about it, but let's see what the
I can try
demonstration
setting
looks
that
like.
time. There's 11, 10. You can also just do it quicker.
And let me tell you, this is great because I have one of those old alarm clocks at home, you know, where it's got the hour button and the minute button, and then you're hitting the button and you're like, okay, I'm getting there, oh, I went too far. Now you get to go all the way back around again.
It also works for setting the alarm and enabling and disabling it.
Very nice. So there's a lot you can do with those buttons. We've also got a slider control on the top of the device, and so we use that as a volume control. And depending on the mode that you're in, it can also adjust the color of the LEDs as well. So since we've got the demo screen up, you might want to go to color, and we can take a look at that.
Sure.
And so that just runs through all these different colors. Very pretty. Excellent. Thanks, Dmitry. OK, let's talk about sensors. You got a little bit of a preview of some of those sensors when I was talking about it earlier. So there's a thermometer hygrometer device that will give you the temperature as well as the relative humidity in percent. I think everybody that I showed it to came by and had to breathe on it to see if their breath would like increase the humidity, which it did. And yes, I was able to saturate the sensor. There's also a barometer that's in the device. It's incredibly sensitive. In fact, it's so sensitive to pressure that if I take an ADK and I hold it up here and then I drop it down here, it can tell the difference in pressure. We've also got, thank you. We've also got an accelerometer magnetometer. So let's switch to the camera again. And so Dmitry's going to show us what that looks like on the real-time display.
So this is a device in accelerometer mode. So blues are negative, reds are positive. So I can rotate it and see the accelerations change. And we can do the same for a magnetometer as well. So I can attempt to find some direction of north here if I knew how to interpret this data. But it does show some random values, so as far as looking cool goes, it works. And the other sensors are here as well. So there's the temperature, 26.3 Celsius. Humidity. I'm not going to make Eric breathe on this. We have the current pressure, proximity, and you already saw the color matching mode.
Thanks, Dmitry. It's funny, when we were doing some rehearsals for the demos, we were running this off of a battery, and he picked this up, and he literally threw it at me, but it was in accelerometer mode, and all the numbers went to 0 because it's essentially in free fall. And so, of course, I was a little scared because here's this thing flying through the air, but then I'm looking at the LEDs. Hey, they're all 0. Physics works.
Unfortunately for you, he did not get hit.
OK, so the API that's involved is very simple, and it actually handles all the calibration calculations, of which there are many, especially that barometer. There was a lot of number crunching that we had to do to get real numbers. But the good news for you guys is that all that code has been done. It's all written, and the API is very simple. You just make a function call here to, for example, baro read, and you just pass in pressure and temperature, and it will go and take those pointers and put numbers in them, and now you've got the pressure and the temperature. It's very simple. All right, Dmitry's going to talk about the sample code for the clock sketch in the Arduino.
Thank you. So the code of everything that I'm demonstrating here, this is all built in. We're giving this code to you, of course. And there's a few interesting things to look into that, and there's absolutely no way I can go through all of it or even a large piece of it. The interesting thing to mention here, if you've ever used Arduino before, is a lot of this stuff happens in the background. Some of it's interrupt-driven, some of it is not. So we actually have a small cooperative multitasking system behind the scenes to let everything happen behind the scenes, like Bluetooth and USB. So once in a while, you have to call ADK event process, which just allows the ADK to process all of its background work. And you can do that whenever you're in a busy loop or in some other such place. And if you don't do that, bad things will happen. So please do. And
so just to go back to that, the multitasking thing sounds complicated. Like, do I really have to worry about that, or is it as simple as making that function call every once in a while?
So if you don't want to play around with multitasking, you just make that function call and everything works. If you want to, you can play around with the multitasking, and it's actually very simple. There's 2 functions really if you care about, one to launch a thread and one to yield. And the thread dies just whenever you return from that function. So if you want to use it, go ahead. It is in the code. And the other example here is how we display the time, and it is just these few lines. I skipped the minutes and seconds, but you just get the RTC and display them. The next line you see there is how the alarm sounds are played for the alarm. And also, we have an alarm preview that does that as well. So if I go to the alarm mode, I don't think we have a microphone on anymore, but it does do that using the OG play background. As soon as I let go, it gets canceled. And also, we have the process USB accessory function, which handles the USB messages that arrive. That gets called in the main loop, unlike the USB code, which gets called from the Bluetooth code, which gets called from the callback. This is actually that callback. And the data arrives, and we pass it to ADK Process command, which just processes the command received and sends back a response. That function is actually in common between Bluetooth and USB. So the protocol is the same. So when you're writing your Android application, you shouldn't need to know or care how you're connected to the ADK. Everything should work exactly the same.
Excellent.
We were really hoping you guys would have a lot of questions, so let's have it.
So there are microphones in the middle of the room here, so if you have a question, please come up and ask it, and we'll do our best to answer.
Shut up and take my money.
Thank you.
Should we mention anything?
No, it's a really impressive piece of kit. I actually had a couple questions about I'm a big Arduino fan. What are you guys running in the Arduino? Like, what Arduino are you running?
What Arduino are we running?
Well, with respect to its amount of capability, is it a? Let's take it apart.
Okay, so I think what you're asking is, this is a 32-bit device, right, and it's clearly running under the Arduino IDE. Right. So what Arduino is it based on?
Yeah.
And the answer is actually that it's kind of its own thing. It's similar in certain ways to the Arduino Due, but it's definitely not the same thing. It's kind of its own animal, but it still retains the ease of use that you get with Arduino. And so if you go to our website and you download all of that stuff, you can just select Google ADK2 and then just start running sketches on it.
So you have your own build, like the play target.
Yeah. Right, exactly. Now, you won't necessarily be able to run all that ADK2 code on an Arduino Due when it hits the market, right? So they are different devices.
Yes.
Yeah, we did work with Arduino for this. We just the timing worked out to where this comes out a little bit before they have their ARM-based things. I don't know the timing on that, but when they do, these ought to be pretty close. So this is kind of a preview release of Arduino for ARM.
Yeah.
It's really, really impressive, this segmented display.
I mean, it's very close. So this is not some strange fork. It's it's based very, very.
We also do have a build without Arduino, just a basic makefile build that we'll be providing as well for those who don't want to use the Arduino IDE for some reason.
Nice. Thank you very much, guys. You crushed it.
All right, next question.
Let's grab the person in the front.
Up front,
so
please.
Alternate.
Hi. So last year's ADK was really more of like a prototype board, which other manufacturers would then create their own variations, maybe at different cost price points or whatever. But this year's ADK seems to be more of a finished product. I was wondering, what is the plan for supporting this outside of your product going forward? Are other manufacturers expected to produce a final good, or are they producing boards which then we then build upon? And the second part of the question is, what, if any, of your convenience code can be shared for ADK 2012 that's not manufactured by Google?
Okay, so we've got a two-part question here. The first part, the PC board files, and that includes the schematics and the layouts and all that's done in Eagle, and that's completely open source, so anybody else is free to make a copy of that and begin manufacturing it. For the second part of the question, I think Dmitry here can answer that.
The source code is also free. You're free to use it. The licensing is very friendly. I don't think we have any code that makes you pay for it. We don't have any code that you have to open your source code for. So you can grab our code, use it however you please. I believe the licenses are all in there, and the code is going to be made available, I believe, right after this talk.
Right.
Yeah, right about
So
now.
if you want to grab the Bluetooth stack, or you want to grab Travis's USB host code, or you want to grab some of the sensor calibration code, you can just grab it and use it by yourself.
So for example, what specific license do you use for the BSD stack, or the BT stack?
The BT stack, I think, is actually licensed Apache or BSD or something of the sort.
Excellent. So it's usable for anyone. Next question,
Great,
please, in
thanks.
the back. You're welcome. Anyone in the back? Nobody in the back.
I think everyone
Next
moved to the
person up front.
I wonder if you could talk about the hackability of the Nexus Q and how you guys came up with that demo and how you would write an application for just a simple Arduino, not an ADK, interfacing with the Nexus Q.
So the important thing to recognize is that the Nexus Q runs full Android, and so it's perfectly capable of running Android applications, and it also has the Android Open Accessory Protocol in it. And so we essentially worked with it just like we would work with a phone.
The main point being there's absolutely nothing special being done for it. You don't have to do anything. It just works.
Hi, thanks for a great presentation. I'm more a software guy than electronic guy, so maybe my question could be very silly, but I heard that there's a problem with USB host that it's also charging the phone, so it's a problem that you cannot charge, you shouldn't charge the accessory from battery because you run out fast of the battery. So is it true? And if yes, is it a better way to make accessories that are work only with phone and are not connected to electricity?
Sure, I'll take this question, Travis. So it's kind of a known issue with the way that USB accessories work. And essentially what happens is the phone becomes a peripheral and the accessory becomes the host. And because of that relationship, the way that USB works, the accessory then has to provide power to the host, which is a little strange. And the reason has to do with sort of the lack of adoption of USB on the go, which I think is rather unfortunate, but it's the world that we live in and we have to deal with it. At the same time, though, a redemptive factor is that Bluetooth is getting more and more popular, especially for accessories. And so I think that it's okay that USB has its limitations because I want people to focus on developing Bluetooth accessories. Wireless really is the future, and that's where we need to be focusing our new development. And it's more fun, too.
Thanks.
I was wondering, the USB audio API that was just announced in Jelly Bean, it didn't really have any documentation for it, and I was just wanted to ask if you know whether it only allows Google Play to stream music out that?
Oh, no, not at all. The, all audio on the phone goes through it at that point. It basically turns it into a...
Okay, so any app?
Yeah, any app. Everything that plays sound goes through it.
So
And
Notifications, alarms, you could even use it like a speakerphone, right?
And this is fully documented on Android side under the Accessory Protocol. I don't know if it's under the Jelly Bean docs or somewhere along those lines, but
It should be on there right now.
Should
I
be
don't
on
know
there
when
right
you
now.
checked,
Didn't really
but there is
have
documentation up on the website now.
there's actually no API for it because it either works or it doesn't, right? And
Any
so-
output you do on audio goes through the device as long as it's plugged in.
Right.
Yeah, and isochronous mode, is that going to be supported, do you think?
Sorry?
Isochronous mode for like high sample rate USB accessories?
At the moment, I believe it is fixed at 44.1 16-bit.
I think he's asking about the packet types being used on USB.
Oh, ISO. Oh, sorry. Yes, no, it's all isochronous, right? It looks like a standard USB audio. Nothing particularly funny about it. It does use isochronous transfers. In this particular case, at 44.1 16-bit, I think it's 192 bytes every frame.
I was just curious, I'm not sure if I heard correctly. It's Cortex, which actual package?
Well, you can certainly open it up and take a look. We're using the SAM3X processor from Atmel.
Okay, cool. And is everything pinned out?
Most things are pinned out. There's a couple of things that aren't because, well, we ran out of Arduino pins.
Okay, great, thank you.
But Eric spent a lot of time making sure all the more interesting things are available for you. So the things missing might be just some bare GPIOs.
That's a good point, and we really didn't have time to mention it in the actual presentation. But when I went through and planned out which pins went out to which Arduino pins, I was very careful to make sure that all the interesting pins that have hardware-accelerated functions actually go out to Arduino pins. So for example, the SAM3X actually can support an external Ethernet PHY, and so I made sure that all those connections made it out to Arduino pins. So that means that somebody, maybe even one of you, could make an Ethernet shield for this device very easily.
And could we actually flash our own firmware too?
Oh, of course,
100%.
absolutely.
So all the code for this is out too.
The code is out, the tools are out. You can grab one and flash it 5 minutes from now.
Yeah, it's very simple, actually. One of the two ports acts like serial port, the debug port, and the Atmel ROM has a loader mode. It's well understood. There's an open source tool called Bossa out there that people use to update these things. And yeah, absolutely, you're flashing it from 0 right on up.
One addition to that is we have our own tool called the ADKTool, which is just used to erase the chip. It just so happens that whenever you plug this into certain platforms that aren't Linux, the device gets erased all by itself because those platforms insist on twiddling the control lines in the serial port. So we have an extra little microcontroller on the board to avoid such unpleasantries. So there's a tool called ADKTool, which we're releasing in source and binary, which you use then to erase the device. Once it's erased, the AppMail bootloader takes over and you can load your own firmware.
It's actually kind of a fun hack because we're using the control lines, and one of them becomes a clock line, the other one becomes a data line, and we actually clock a little magic number into this tiny little microprocessor, and when it sees the right code, then it tweaks the erase pin. And so you don't have to interact with any physical buttons to erase the code at all. Question?
And my question is about the NFC. And according to the document at the developer site, and using NFC, using by NFC, lock the device by NFC, lock the device, and unlock the device, then enable. So my question is that firmware code can interact with some Android devices by through NFC or DEP or some protocol.
Okay, so the question has to do with NFC, and we have an NFC tag on the device, and that's a passive tag, and what it does is it sends your phone to Google Play to download the application. We didn't lock it, so it's in read-write mode, which means you could peel it off and put something else on it if you want to. The ADK itself doesn't really support NFC at this point, although if you're interested, you may be able to put together a shield for us, which would be awesome.
Have you guys explored the possibility of building a REST API to allow maybe HTML, JavaScript interaction? I know with the Raspberry Pi, I've explored that, and it's really accelerated prototyping.
Well, I mean, this would make a little more sense if we had a network-connected device, but we don't actually have Wi-Fi in this device, so maybe once we have Wi-Fi.
I meant on the Android side of it.
Oh.
So the actual server REST API would reside on the Android device, and you could actually have HTML5 apps that would interact.
I don't think any of us have thought about it, but you can implement it. I mean, the API to talk to this is available, so there's no reason you can't do it, and then we can come and ask you questions about it.
No, but I'll bring that up as something to talk to the
I like that
accessory
idea,
developer. So yeah,
That
absolutely.
could be pretty interesting.
Can you speak a little bit about battery life and power consumption? Of course, it depends what it's running, but for instance, are there low power modes, and what are some figures for battery life and power consumption?
So I don't think we ever meant this to be a battery-powered device. There's a hole in the back for all the cables, including a power. But I have run this off battery, and it runs. I don't think we've actually measured the battery consumption. I don't think it was ever meant to be such a thing.
So yeah, just to talk about the electrical aspect of that, you could certainly take the base shield and power that from a battery. The SAM3X device actually includes a fairly complicated power management device that will allow you to go in and throttle the clock down. So it's actually got a full-blown clock tree, and there's a lot of stuff going on in there. Most of that complexity is available if you want to hack on it, but for people that just want to get it working as an alarm clock or play with Arduino, it's all hidden, so you don't have to worry about it if you don't want to. But if you do want to worry about power consumption, there are definitely ways to go in there and tweak that. Now, obviously, if you're running all 64 RGB LEDs and got some bass thumping on this thing, it's really not going to last that long.
It does work on battery, though, so I can actually show that.
Oh, look at that.
You can do it.
So you guys mentioned just a minute ago that you could have one of these flashed in 5 minutes. So I'm just kind of curious. I came in a little late, so maybe you said it, but what's the availability on these devices, and how can we get our hands on them?
I believe all you already will get your hands on it.
That's actually a really good segue. Since we're nearing the end of the session, everybody in this room is going to get their own ADK.
Just a question out of curiosity. You said you checked the Bluetooth connection with the various other platforms. Does it include a major rivaling mobile operating system?
I don't have a Windows phone, so I can't tell you that. However, However, it does work with another rival operating system. I actually use mine at home to play music off of my iPhone.
All right.
Is that the one from a certain Cupertino fruit company?
Thank you.
Are you providing any reference schematics or PCB docs?
Absolutely. So they're all being posted on the website in Eagle format, so you can pull them up in the free version of Eagle and start hacking away.
What's the current and future status of availability of shields for this? So, I mean, it's fairly standard pinout, it looks like, but I'm just wondering if you can sort of talk about what's out there that can be already plugged into this today.
So the device is compatible with any Arduino version 3 shield, and that's because it's a 3.3 volt device, and so any shield that wants to use that needs to have its own onboard level shifters. And so the V3 Arduino shield format includes that in their specification. So there's a reference pin that you use to set the reference voltage and communicate that onto the shield. And so if you have a V3 shield, you plug it in, it should just work. Yes?
Hi. How much memory do we have on the Arduino itself?
So there's a few memories here, so let me go over them. The SD card the units come with, I believe, is 4 gigabytes. The device itself has 512 megabytes of flash for storing code and constant data.
Kilobytes.
Oh, I'm sorry, 512 kilobytes. Wistful thinking, I must say. And the device itself has 100 kilobytes of RAM as well. There's 96 contiguous kilobytes and there's also 4 more in the NAND controller, which we're not using, so you can use those as well. So it's about 100 kilobytes of RAM total.
Okay, great. Thanks.
Mm-hmm.
Hi, could you also elaborate on availability for things like, educational discounts or just general consumer buying the device in the future? What the plans are going forward?
At this point, it's a giveaway for Google I/O. There may be some future plans. All I can say is stay tuned.
Okay, thanks.
Okay, great. Any more questions?
I think there's a person raising their hand right there.
I don't see any hands.
No? Must have been stretching.
Okay. All right, thank you very much. Good. And before you guys leave the room, please note that for the giveaway, there are going to be people by the doors holding cards. Be sure to grab a card because that is your ticket for your free ADK that you can get at the stuff booth on the first floor. Thank you for coming.